Thank you for introducing me. My name is Farzaneh. Hello, everyone. I'm glad to have such great opportunity to have a webinar about this topic with the title as Machine Learning Trends in Cybersecurity. In this presentation, I will start with a general introduction and definition. Then we will review cybersecurity and various domains. After that, I'm gonna present dimensions of machine learning schemes. Then we will review different kind of machine learning uses in cybersecurity domain. At the end, we will have a conclusion and question answer. Let's start with some definition. What is machine learning? Regarding Google's definition, machine learning is a type of artificial intelligence that provides computers with the ability to learn without being explicitly programmed. Machine learning focuses on the development of computer programs that can teach themselves to grow and change when exposed to new data. What is data analysis? Data analysis is a process of inspection, cleaning, transforming, and modeling data with the goal of discovering useful information, suggesting conclusion, and supporting decision making. And what is cybersecurity? Cybersecurity is a body of technologies, processes, and practices which are designed to protect network, computers, programs, and data from attack, damage, or unauthorized access. In a computing context, security includes both cybersecurity and physical security. Cybersecurity is the intersection of computer security, network security, and information security. So what's happened when all these terms comes together? Machine learning has been quickly adopted in cybersecurity for its potential to automate the detection and prevention of attacks. ML models have fundamental advantages compared to the traditional ones, including the higher likelihood of identifying novel zero-day attacks and targeted malware. Data science and machine learning can significantly change the cybersecurity landscape. Actually, their goal is providing data-driven intelligence decision-making from security data. In this figure, you can see that the popularity of this related technology is increasing day by day. This diagram is plotted based on the data of the last 5 years collected data from Google Trends. It shows that the popularity values of this area are less than 13 in 2014, and while they exceed 70 in 2019. It means that more than double in terms of increased popularity. Though cybersecurity is a single term, it involves the coordination of the various other domains to guarantee the security. These domains are listed here in this diagram. Application security, which is related to improving the security of an application. Information security, which is related to maintaining the CIA of data and information. Network security, which is related to shield the usability and integrity of the network and its data, and other domains like operation security, internet security, ICT security, and end user knowledge. The last one means that the lack of user knowledge about the cybersecurity risks is the reason of 50% of the cyber attacks, and almost 90% of cyber attacks are caused by human behavior. It's important to understand that machine learning is not a panacea, but it can provide a great deal of support to a cybersecurity or IT teams. ML may have a long way to go before it can be used for threat detection on its own without human intervention. However, there are many tasks that machine learning approaches can handle to level up security, such as classification, which means classifying the security data based on predetermined parameters or classes. Clustering, for data that doesn't fit present parameters, ML groups data based on their similarities or anomalies. Recommendations, it means learning from past decision inputs and feedback to recommend new approaches or decision. Generative framework, to generate a possibility that can be applied to data based on the past data input. And prediction, to predict the future based on the data set and previous knowledge. Let's take a look at the general taxonomy of different kinds of machine learning methods in this area. The various ML methods can be grouped under three main categories: supervised, unsupervised, reinforcement learning, or semi-supervised learning. The first category is supervised learning, where the learning process of the agent is based on the labeled data. It can learn a function or model with the ability to map the input to the corresponding output based on the label training dataset. Based on whether the target labels are discrete or numeric, the learning process is defined as a classification or regression. The output of the classification is a set of classes. These classes can be binary, such as anomaly detection, or more classes, such as detecting the types of malware. On the other hand, the output of the regression is a continuous value. The main difference between supervised and unsupervised category is the availability of the classes label. In unsupervised learning, all input samples are unlabeled, and this category includes dimensionality reduction and clustering. Dimensionality reduction can be utilized in autoencoders and reduce the dimensionality of the input space of the problem. In addition, they can be used to reduce the noises or redundant data. Clustering is generally utilized to group data based on their similarity using mathematical probabilistics or statistical means. The third category is reinforcement learning. It is considered to be somewhere between supervised and unsupervised learning because the input has no label information, but instead the input would be associated with a reward value. This type of methods is widely used whenever we want to design an agent to discover a new and unknown environment and gather knowledge with its experience to find the best action or decision at each time. To name some top use cases of ML in security in real world, we can mention detecting threats and stopping attacks, analyzing mobile endpoints, and enhancing human analysis. In the last 5 years, modern cyber attacks have used intelligent techniques to bypass the cyber defense system. Nowadays, there has been an increase of cyber attacks in different organizations because of the beginning of the COVID-19 pandemic. There are different types of cyber attacks based on how they attack a system and which system components they target. In this diagram, you can see 6 types of threat categories, such as sniffing, intrusion, phishing, malware, and spam. These cyber attacks can attack one or more system components out of the 4 main ones, such as network, application, user, and endpoints, which means the end user devices such as laptops or mobile devices. In order to protect these 4 components, the cybersecurity framework needs to ensure that the task of threat prediction, detection, prevention, and monitoring are implemented correctly. Fan and his colleagues published a survey paper about machine learning for security and IoT. They consider the good, the bad, and the ugly use of machine learning for cybersecurity. In details, they consider the several benefits as a good use that machine learning has brought, such as the improvement of the intrusion detection. They also consider the vulnerabilities of machine learning from the perspective of security as a bad use of machine learning. This type of perspective includes the ways in which machine learning system can be compromised or misled at each stage of the learning life cycle, such as data collection, pre-processing, training, validation, and so on. Finally, they also talk about the most concern aspect of the using machine learning technique in cybersecurity domain as the ugly use of ML, which means utilizing machine learning in the execution and generating novel and new cyber attacks and intrusion. Because the machine learning techniques have a powerful data analysis abilities, they can also be used by malicious adversaries to analyze the vulnerability of the cyber system, as well as assist in the attack detection. In this diagram on the left side, this diagram shows incomplete view of the machine learning algorithm and application in security. The various algorithms that are used in the cybersecurity in the good use manner can be typically grouped under supervised and unsupervised method. The former category contains all the problems such as malware and spam detection, where we have a good label data set. The latter is where the data set may have mislabeling, such as risk scoring and anomaly detection problem, where the data set might contains only the normal samples. Let's consider clustering, dimensionality reduction, and association rule learning as the main approaches within unsupervised learning. All of these approaches are useful to make large amount of data to analyze or understandable for human expert by reducing the number of dimension of data or grouping the data. Microsoft Azure machine learning is a great example of good use of machine learning that currently being applied in cybersecurity. It gives you the opportunity to build, train, and manage your own model. Here on the right side, there is a list of some benefits of using machine learning techniques to cybersecurity related tasks. For example, phishing and spam detection with a state-of-the-art classification models such as deep learning can help the security teams to classify internal data, spam, and malicious activities with predetermined parameters or classes. Authors consider adversarials weakness in machine learning as a bad use of machine learning in cybersecurity. Attacks against machine learning models have the potential to degrade the system performance when such models are used as a critical component. Adversarial learning can be applied in different learning stages, such as attack on data collection, attacks on the training phase, or attacks on the testing phase. For example, for attacks on the data collection, generally speaking, we can consider generic attacks such as evasion, poisoning, and exploratory attacks that should be tampered with the system during the data collection and preprocessing stage. The second category is about attacks that directly target the training process by either injection modified data into the training set or by manipulating the training logic so that the training result can be affected. Two attacks strategies such as data modification and injection and the logic manipulation can be considered to target the training phase. The last category is related to the attacks that attempt to induce the model to output incorrect result after training the model has been incomplete. The attack on the test phase can be done in either a white box or black box manner. In a white box scenario, an adversary has a perfect knowledge of the model parameter and the structure of the target model, such as the type of the neural network, the number of the layers and neurons, or the size of the input tensors. While the black box attacks assumes that there is a little knowledge about the model. The last but not the least category of machine learning use that is the researcher consider is the ugly use of machine learning. In this category, machine learning has been utilized as an attacking tools against cybersecurity. Here, adversaries leverage ML to analyze the vulnerability of the cyber systems because they widely use the data analysis to improve performance. In the cyber systems, machine learning and neural network can be utilized by malicious adversaries to enhance some types of existing attacks. Or machine learning can also be utilized to attack a verification code system and gain unauthorized access. For example, Roseberg proposed a CNN model to recognize verification code and obtain access authentication. In this category, adversaries utilize different ML models in different malicious uses, such as malicious access, evasive attack, or phishing. There are also some other malicious uses of ML, such as developing a model to attack on games or gambling, or using machine learning models to learn optimal strategy for auction scenario and competition, or developing model for human-centric attack. And the last one is turning ML models with the aim of backmail and target delivery. Smart cybersecurity services is an example of a good use of machine learning in the cybersecurity domain. Sarker and his colleagues propose a generic multi-layer framework based on machine learning techniques for smart cyber security services. Figure on the right side shows an overview of this framework. This framework involves several processing layers from raw security events data to the service. The first step is collecting valuable data. It is an important step where the data sources can be classified into several broad categories, such as network, host, or hybrid. After collecting the raw security data, the next layer is responsible to prepare the raw data for building the model by applying various necessary processing, such as data cleaning, normalization, and transformation. The next layer is machine learning-based security model. This is the core step where knowledge would be extracted from the data through the application of cybersecurity data science and machine learning. To have such knowledge and insight, various ML techniques can be involved in this layer according to the solution perspective. For example, techniques such as security feature engineering that is mainly responsible to transform raw security data into the informative features, or malicious behavior or anomaly detection module is typically responsible to identify a deviation to a known behavior, where clustering-based analysis and techniques can be also used to detect malicious behavior or anomaly detection. The last layer is about incremental learning. It is concerned with finalizing the security model by considering the dynamic of the environment and data, and also using additional intelligence component according to the needs. For example, the post-processing and improvement module in this layer could play a role to simplify the extracted knowledge according to the particular requirements by considering domain-specific knowledge. To recap, in this presentation, we discussed different machine learning approaches in cybersecurity domains. Machine learning does something really well, such as quickly scanning large amount of data and analyzing them. Cybersecurity systems generate a large amount of data, so it's no wonder that the machine learning is a useful tool. It is promising that just looking at the past data to train a model and predict the future. But please note that the domain expertise is really important in this equation. Uh, there are groups of people who think you can learn everything from the data. This is simply not true. There are some cheat sheet to show you how to use a proper machine learning methods for a problem. Most of these cheat sheets are publicly available. You can easily use them whenever you want to use ML techniques to solve your problem. Um, Also, please keep in mind that malicious actors started to develop AI-based bot to generate cyber attacks in the last few years. So cyber defense methods are not sophisticated enough to capture new threats and protect IT systems. Carefully designed and tested machine learning methods have to be deployed in order to meet the complexity of the new cyber attacks. Yeah, here is some references that I use for this presentation. Thank you for your attention. I'm here if you have any question.
Thank you very much, Farzaneh. Thanks for this great presentation.